Hello class and welcome to APLTRIG Laboratory. Now today we're going to discuss the quiz that you took last meeting. Then since that you've learned about the trigonometric functions, we can talk about that and the use of it in games. Then in the end, I want you guys to answer a activity. Now the answer to the activity I will also share it in the end, but please try to solve it by your own first. All right. So now let's go on to the quiz. So the quiz, it's about a sniper, right? So there's a sniper, which is the gear, which is found on the right side of the map on top of a stone wall. And the sniper is pointing downwards at an angle. And assume the angle formed by the sniper is 58 degrees, where the adjacent is the building wall, and the hypotenuse line is the side of the tip of the box wall. So we will go on to the box wall later on. For precision, assume that the exact point given is the lower left of the gear image, and the position of the sniper given is also the highest step of the building, which is top left of the building. So we have some numbers here. So we have gear X, which is 576, gear Y, 256, and then we have the angle. So there's a wall of boxes that covers the target. The point given is the highest point of the wall. So we have the wall tip here, and then the wall tip Y here. So this wall is this. The target, the clown, is behind the box wall. The according to the target is as follows. We have the X, which is on 224 right here, and then the Y is on 0 down here. The head is at 32. Right. So this is a really rough display of it. Now, question 1. Assume that the right triangle is formed from the position of a sniper, the tip of the box wall, and a point somewhere here in the building. The triangle will be triangle 1. What is the distance from the point given of the box wall to the sniper's position? So be sure to save the answers. So we have all this here. Now, it's asking what is the distance from here to here. Given that we have the height of this, which is this, gear Y, 256. We have that height, and we also have the height of this, the wall. So that means we have the distance from this, from the Y. For the X, we have the X value here, it's 576. And then this, for the box wall, we have X of 320. How do we use that? So we have X, which is the gear X minus the wall tip X. Then for the Y, we have gear Y minus wall tip Y. So again, important that we have the same X and Y. So we have the X on the gear, the Y on the gear. We minus it on the wall tip X and the wall tip Y. So that's important. We can't have the wall tip exchange with the gear Y all of a sudden. So now we have that. We have the math square root. So if you remember the distance formula, we have the square root of the X plus Y. So the square root, X squared plus Y squared. So we have X times X plus Y times Y. So let me just put this in parentheses. When we play this, the hypotenuse is 302. Alright? So that is for question number 1. Question number 2, what is the distance between the point given on the wall with point of the wall of the building that will form the right triangle. Another way to look at this is how distant are their x positions. So just like a while ago, we have our x here. I can do this again. We have gear underscore x minus wall tip x. This is what is the specific point given on the wall with the point of the building that will form a right triangle. So yeah, gear x minus wall tip x. 256. So that is his, right? So our hypotenuse while ago is 302. This is 256. So if you're right, this should round up to around 58. Right? So if there's something wrong here, then it would not have given a 58. Okay? So question number 3, how far is the base of the building wall, not the box wall, okay, to the foot of the clown? So how far is the base of here to the clown? So we have our wall tip x minus, let's get the clown. The clown is clown x. Clown x. Sorry, not wall tip. My bad. It's gear x. Gear x. There we go. The distance from the clown is to the wall here is around 352. Next, question number 4. Assume a second right triangle is formed from the sniper's position, the base of the building, and an imaginary point where the line of sight the sniper would see the floor passing through the tip of the box wall. So imagine there's a line here, right? So we're looking, there's a imaginary point here, there's a point here, and then there's a point in the sniper. So it will have the same angle still as triangle 1, which is the 58. So using the trigonometric functions, what is the distance from the imaginary point P to the base of the building? Be sure to save the answers. So this part, you need a bit of trigonometric functions. That's why I've put it down here. I've written here the hint. So we have sine of an angle is opposite over hypotenuse. Cosine angle is the adjacent over hypotenuse. Tan angle is opposite over adjacent. So again, what do we look for here? What is the distance from the imaginary point P to the base of the building? So first we have 58 here. We have this here, right? This is given. We have also an angle, which is 58. So this is the adjacent, this is the opposite, given we're looking at the angle here. So adjacent here is, where is that? We have here? No, I didn't write it down. So we have the from y here to 0, which is clearly just gear y. And then we just have to find this. So using, now since we're looking for this, you're gonna use tangent. Why? We have opposite right here, which is how far that we want. And then we have the adjacent here, which is gear y. So let's solve it. So supposedly tan, what angle are we using? Tan, we have here, tan angle, right? So we have tan angle should be equal to opposite over adjacent, the opposite divided by the adjacent, which is basically gear y. Okay? Since we're looking for opposite, if we use a bit of algebra, we have to have this in just one side. So multiply both sides by gear y. So gear y times gear. So what's gonna happen, since gear y is at the bottom gear, and then we try to multiply that, it becomes 1. So it's gone. It's a bit confusing here when in just text. So gear y times tan angle is equal to opposite. So just line up side of x here. That's opposite. So hold on. So we times gear y, and then just for sine, since it's using radian, let's put in here angle. So this is our, oops, not sine, but tan. So this is the tangent times the gear y. That should give our line of sight of x, which is this line. We move this, we play. So triangle to opposite is 410. So this line here, from here to the imaginary line here, the line of sight, this one here is 410. Question 5. Will the foot of target be in the range? So we're looking for the foot. Will the foot of target be in range of the sniper's sight? So if you remember our x here is 224. You have anything here? Did we try to solve that? No, we didn't. So we can just manually do that. So we have clown x, which is 2 to 4, minus, what is the x of the gear? 576. 576. Of course, you do absolute value. That should be equal to 2, 3, 352. 4, 5, 7, 6. Okay, 352. Well, the thing is, the sniper can only see, since there's a wall, right? There's a wall here. He can only see from 410 and more. But since the the clown is like 352, which is below, before that line of sight here, that means he cannot target the clown. So the answer is no. No, he will not see. The sniper will not be able to see the target, right? So optional 1 here is you don't have to solve this, but it's just for you to see. So we have here, right? And option 2, they just want you to create a line. So how do you do that? If you remember your, I think it's algebra, y is equal to mx plus b, the slope function. Remember, the slope is the y over x. We have x here, that's given. B is the y-intercept. So if I do this correctly, hopefully it's correct. So the slope, we have, let's put it here. Again, we have x. So we have gear x minus wall tip x. We have y, gear y minus wall tip y. So that is my wall tip y. the y-intercept, I believe, should just be wall tip y. Okay, so let's try to solve this. So y is equal to mx plus b. M is y over x. That's our slope. We multiply that to x. That is this one plus wall tip y. This might be wrong. Yeah, it's wrong. All right. Wrong. Let's call this x. X. Yeah. So it's x2. Let's call it x2. Yeah, butcher that one. I believe you have to also move that to the right because we have x. So what is this? Right. So we do have to minus this with wall tip x. And there you have it. So this is our line here. And then this is the imaginary points that we were talking about in question 4. Right? So clearly it does not hit. It won't hit the clown's feet. If you move the clown to the left, then of course it would have been hit. Okay? So yeah, this all you have to do was this parts questions 1 to 5. If you got it right, then good job. If not, that's okay. We still have more quizzes to go. All right. So, if you have questions here, just feel free to message me or message the group in Discord. Then we can talk about that. Okay. So, now I know that you guys have learned how to use trigonometric functions, right? So, what is the use of trigonometric functions in game dev? Now, depends really on what games you are trying to make. So let's say the easiest one, bullet hell. For bullet hell games, of course, you want to create patterns. You want to create patterns so that the player has to try to dodge those bullets that are incoming. Right? So if you don't have bullet hells, sometimes you're like circle patterns, and from that it will just expand, continue to expand, and then they're like bullets here. So there will be some opening spaces for the player to pass through, right? But the thing is, how are we able to create that pattern dynamically? Because we don't want to like manually put in each point of that circle. Because remember, we are working with a Cartesian plane. We don't want to manually say, okay, yeah, always put a bullet around these points of circles. One, that is dirty. What's gonna happen is let's say you have a game object like a player. Sorry, the enemy. And then all those points, let's say you manually added those using like a empty object. It'll be like 0.1 here, 0.2, etc., etc. And that is really messy. As game developers, we try to make things as clean as possible and efficiently. This is inefficient. because what happens if you have another another kind of shape that you want? Maybe square. From square, it's gonna shoot from whatever angle that it was, right? That's gonna be messy. So instead, we can actually use trigonometric functions such as sine and cosine. How? If you remember, given an angle right here, you have an angle here, angle theta. If you use a sine and cosine in a right triangle with sine theta, you would have this opposite over the hypotenuse, right? Then for for cosine, you have, oh sorry, that's not x, that should be y. For cosine, you have cosine x here, adjacent over hypotenuse. The hypotenuse can be whatever. You can give it a number. Depends on how far you want it from your enemy. Let's say it's only one, or maybe let's say 5 units, right? So hypotenuse, automatic, that will be 5. So how do we know what is this point? So you have sine and cosine. So remember, sine theta is equal to opposite over adjacent, right? In this case, we have the y over, adjacent only, opposite over hypotenuse. In this case, we have sine theta is equal to opposite, which is that y, over 5. So how to get y? We just multiply that to the sine. So 5 times sine theta is equal to y. Same thing with x. So remember, cosine theta is adjacent over hypotenuse. And our adjacent is equal to x. Our hypotenuse is equal to 5. So how do we get x? We multiply 5 in both sides. So 5 times cosine theta is equal to x. So now we have a point. We have x and we have y. With these 2 points, you're able to place in wherever that bullet would be. And we do that for each. Let's say we want to split 360, like a circle, right? We want to split 360 with 10 points. So for each one, it will be 36, and then next one will be 72. And then from 72, we have 108, etc., etc. And we can use that for our sine here. Okay, so you have 5 times sine 36 is equal to our y. And then 5 cosine 36 is equal to our x. So we have a point here. Next one, we have 72. So 5 times sine 72, that will be your new y. And then 5 times cosine 72, that will be your new x. So we continue to do that until we finish our circle right here. So if you want 10 points, you have that. So if you want 20 points, of course you have 360, because again, that is a circle divided by 20, then you're left with 18. So for every 18 degrees, you're gonna compute. Okay. Now, it really depends. Again, how far you want it to be. If you just want it to be one unit far from your point, of course you just make it one. So let's say one lang. So same thing. One sine theta will be the y, and then one cosine theta, this will be your x. Okay? So that's one way. That's one way to use trigonometric functions, just so you can dynamically create things. This is quite useful. Okay? This is quite useful if you have knowledge in trigonometry. You're able to use this for games like this, like our bullet hell. And I'm not sure if you've reached this, but there are also those airplane games. I think that was um, 19 something something. It's the one where it's a top down, and then you just move the plane left to right, and there are incoming enemies on the top of the screen. So mga ganun. So if you want a spread, let's say, let's clear this. If you want a spread, let's say this is an airplane, right? A spread where it shoots like this. We still use trigonometry here. Okay, so we still use that. So let's say you want these 3 points here, and then they just keep going, right? We can solve these points again by using angles. So let's say for every, let's say this 3, right? Let's say this 3 in a let's say 90 degree. So this let's say this forms a 90 degree. So you have 90 degrees, of course, divided by 3, you have 30, right? So you have here, and then this is 30, and this is 30. Then, with, again, sine and cosine, you're able to tell where it is. Of course, medyo na offset to. Since it's offset by, because we have our normal Cartesian plane, right? This is supposed to be going positive. But this, however, is down here. So you have to offset it by an angle. In this case, since we're creating a 30-30, this one would probably be 30 here. Hold up. 90, 60, and then 70. Okay. Yeah. You have to offset that angle. So, of course, you'll add maybe 180. 180 times, yeah, sorry, 180 plus, so whatever angle we're working with. And then again, you have sine and cosine. And then how far you want it to spawn. So maybe hypotenuse will be 5, right? So again, your x and y will be cosine 180 plus theta times 5. That is our x. Then we have sine 180 plus theta times 5, or hypotenuse. Okay. And then you do this for 3 times because we have 3 points. Okay, so that's just another way to use angles and trigonometric functions. Right? Another one I could think of is probably another 2D game. Let's say 2D game. Let's say, no zombie games. You have your character, and then We have, of course, those zombies incoming, right? So you also have a gun. Let's be that color red. So you have a gun. And the thing is, to balance out some games, they don't want to shoot straight, right? They don't want you to, let's say you're aiming your mouse here. They don't want you that it will automatically aim straight here. Sometimes they offset it by a bit, maybe a bit lower, a bit higher. They offset it a bit to introduce like recoil or precision. And again, it still uses sine, cosine, tangent. Now that we have an angle here. Sorry, let's make it color blue. Let's say our crosses is here are, ooh, that's not blue. Here. Let's say their crosshair was like this, in this position. The game will verify how far this crosshair is from the player. They already have that function. Like they get the distance. The point here. So we have the mouse position. Ooh. Mouse X and mouse Y. Okay. And then you just correlate it to the position of your character, which will be like player X and player Y. So of course you can just minus these. But you should be able to get this triangle right here. And then we have that angle right here. Right? So what we can do is when we shoot, we base it on this angle. This is one way, okay? We shoot based on an angle. And if you want to introduce so the inaccuracy, we can actually add or subtract this angle by, let's say, 5 degrees. So instead of being exact, we can maybe randomize it from 5 to -5. So it could either be like down here, maybe, or up here. Okay. So this introduces inaccuracy, which makes the games balanced, or it makes the game, more realistic. We have those things. We can introduce inaccuracy by changing the angle. Okay. So that's one. Another thing, you can also introduce that for shotguns. So for shotguns, right? The same thing. Let's put a guy here again. Guy here, and then his gun right here. For shotguns, you want to spread it out, right? Again, it is lazy if you have like 3 points right here or 4. It depends on how much you want, and then you keep them maybe in the player or in the gun, so that 3 points will always be there. For me, this is lazy. There's like so many ways to. What if the designer wants to add another point? So you would have to like manually add another point here. But what if the designer wants to change it? So you have to now remove sub points. And the thing is, this angle right here, you have to change it so that it isn't pointing up anymore. You have to you have to move it down here and stuff. That's very time consuming for you as a programmer. So instead of that, we can set, let's say, our angle. So the spread maybe would just be within 30 degrees. Okay, so just within 30 degrees. So this is 30. And we just have to randomly shoot within this 30 degrees. So what we would usually do, so if you remember our Cartesian plane right here. So if it's within 30, I want it in the middle. That means this should be within negative 15 to positive 15. And with those angles, we randomize that one from negative 15 to positive 15, randomize it, we get a point, we get an angle. So now we have our angle, and then again, up to you how far you want it. We have our hypotenuse, maybe 1 unit, and you can now again get your x and y values using cosine theta and sine theta. Okay, so there are so many uses. There are so many uses for this. It is quite important, yung trigonometric functions. Even tangent is quite important. That's right. Was here? Right. Well, tangent, more of like a tangent, but then that's from the reverse of tangent. But anyway, it could still be used. Right? So there are more applications for this. It can also be used for 3D games. It doesn't have to be 2D. Okay, so yeah, there are so many more applications. For 3D, it becomes a bit more complicated, but it should work on the same principle using sine, cosine. You just have to know which angle, because now it's not just this, but we even have the z-axis. So either you have to use this angle, or you have to use this angle, or you have to use this angle. Right? So again, up to you. Kasi marami na eh. Hindi na siya 2D. You just have to use it correctly. Right? So again, same principle. So yeah. That's it for using for games. If you have any questions for like how to use angles for certain games, you can freely ask. Or if you want another example, like shoot out like another game, how are angles used there, just message it to group, then we can both find out. We can all find out how angles are used there. Right? So that's it for this discussion. For your activity, make sure to go to the quizzes. It's an exercise. Solve for the line. So let me just put exercise here, but in this exercise, you have to answer 5 questions. So given we have a line segment GD, which is 1.2, we have a line segment EF right here of 3, and then line segment GH of 1.31. Angle EGD is 59.04 degrees, and FAD is a rectangle. So determine the following. What is the angle DEG? So we are looking for this angle, DEG. Number 2, what is the length of the line segment EB? EB. So we're looking for this. That is line segment EB. What is the length of line segment BF? So BF. What is the length of this? What is the length of line segment CE? So what is the length of this? And finally, what's the length of line segment AC? Okay. So I will discuss the answer in 10 seconds, but make sure that you pause here and then try to solve it yourself. So this one is not really graded. It's okay to feel this, but again, do try. Do try to get it right. Okay, so in 10 seconds, I will start discussing it. Okay, so number 1, what is the measure of angle DEG? Right here. Oops. Right here. Given we have a 59.04 for angle DGE, and remember a triangle, if you add all the angles, is made up of 180 degrees. So we have 90 plus 59.04 plus blank is equal to 180. So our answer would be if you minus both sides with this. So 180 minus 90 minus 59.04 is you will get your angle. So calculator. 180 minus 90 minus 59.04, 30.96. So this is 30.90. Let me make this smaller. A bit too small. There we go. That is 30.96. So that is number 1. Number 2, what is the length of line segment EB? So again, we have given EF. EF right here is 3. Let's make this here 3. Okay, this is 3 EF. What is the length of line segment EB? So given our angle, so this is 33.96. So what is this? This will be 59.04. Okay, how do you do that? We could do like 90 minus 30.96. Right, you could do that, or it's a special rule where if you have two parallel lines right here, this angle will be equal to this angle, right? So or you can just do this. Okay, so this is 3, this is 59.04. So Sokotowa for sine, it's opposite over adjacent, but we don't know our opposite. We have cosine, which is adjacent, is 3 over hypotenuse, EB, which is what we need. So we can do that. So cosine 59.04 is equal to adjacent, which is 3, over hypotenuse, which is EB. Then we want EB on just one side, so we divide both sides by cosine 59.04. We are left with EB is equal to 59.04 divided by, 3 divided by cosine 59.04. So we bring this out, 3 divided by 59.04 cosine. We have 5.83. We want to round this up in 2 decimals. 5.83. So EB, oh no, let's make this here. Color green. 5.83. 5.83. Okay. Next, what is the length of line segment BF? So we have B here, F is here. So we have our angle here again. We have adjacent, which is 3. We can use this if you want, or we can just use whatever we have, which is our adjacent here. And what we need is opposite here. Let's use a different. So remember, tangent is opposite over adjacent. So tangent 59.04 is equal to SOHCAHTOA opposite, which is BF over adjacent, which is 3. So now we leave BF in one side, so we multiply both sides by 3. So we get 3 times tangent 59.04 is equal to VF. So 3 times 59.04 tangent. That times, I messed it up. 59.04 tangent. So BF is 5. Okay, BF is 5. Let us put this down here. 5. Next, CE. What is the length of line segment CE? Now the thing is, FABE never mind. Yeah, okay. For line segment CE, okay, so we have our, for line segment CE, we have 5.83 right here. Okay, we can't assume that this is a perfect rectangle, right? Though we know this is 30.96 right here. And we know that 5.83 is the length from EB. So to get CE, we can use another color, light blue. So SOHCAHTOA for cosine that is adjacent, we're using this angle, adjacent of C, which is CE, over hypotenuse, which is 5.83. So cosine 30.96 is equal to CE over 5.83. Cosine 96. Okay? So we want CE again, just one side, multiply both sides by 5.83. So 5.83 times cosine 30.96 is equal to CE. So 5.83 times 30.96 cosine 4.99 or 5. So now this line is 5. Finally, what is the length of line segment AC? Line segment AC, which is right here. For line segment AC, we know that FADE is a rectangle, which means this right here, let's make it color this one. This is 3 also. The thing is, we don't know what a CD, but we know that CD is made out of DE plus C. Sorry. We know that CD is this CE minus DE. We have CE, which is 5, right? We did that already. Well, what is DE? For DE, we have our angle here, 59.04. We also have the line segment GD, which is 1.2. 1.2. Okay, so what is DE? Using tangent 59.04 is equal to opposite DE over adjacent 1.2. So we leave DE on one side by multiplying both sides by 1.2. 1.2 times tan 59.04. Hence 1.2 times 59.04. Oops. 59.04 tangent 2. So we know this is 2. DE is 2. And again, CE is made out of CD plus DE. So CD, which is 5, minus DE, which is 2, we are left with 3. So this line right here is 3. So we have we know this, we have 3 here, we have 3 here. So what is this line AC? So we have trigonometric function of the Pythagorean theorem, which is a squared plus b squared equals c squared, because we know this is a 90 degree, right? So 3 so AC is equal to the square root of 3 squared times the orange 3 squared. So this would be 2 times 2. Oh, sorry, 3 square root of 2. All right. So we can just 3 times 3 plus 3 times 3, and then square root. Oops. Square root of 18. We have 4.24. So line segment AC is 4.24. This is 4.24. All right. So I hope you guys got it. So in this one, kasi we don't have any angles here. We can't assume what are these angles. But we know, you say right angle, we know the 3 here, we know this here. So we can solve this line. Okay? So I hope you guys got it. If not, that's fine. You just review more on this. But if you have any more questions or concerns, feel free to message me or message in the Discord. So I hope you guys learned something from this, and I'm pretty sure this will be very useful in your future endeavors as game developers. All right. So yeah, that's it for today. I hope you guys have a nice day.